Hello, welcome to another lesson. This is page 25, coming hot off of page 24, and we're going to be dealing with the other truth tables. So in this video, we're going to be covering NAND, NOR, and XOR. So it might be a nice idea to write down that the other truth tables are NAND, NOR, and XOR. All right, what do they mean? They mean not and, not or, and exclusive or, and we're going to get into the details about that in a second. These compound statements, they are much harder to relate to English statements, but they're super important in computer logic. So we cover them here, and then you're going to see a bit more of them in the next topic. In fact, you're going to see a lot more of them in the next unit. You might want to take a look at this website, follow that on your own time, and just read through it. Not everything is relevant in there, but it's always nice to see things from a different point of view. And you might be able to apply what you find on this website to your future work with coding or something else. So let's move on and see what NAND means. Well, NAND means not and. So literally, whatever and is, it's not that. And you'll see that the symbol supports it. This symbol here, normally this is and it has the not on top. So the symbol is literally a combination of and not. If we look at the logic gate that relates to this, which we'll see more of in the next topic, you'll see that it's a not, that's the symbol for not, related to an and gate. That's foreshadowing for the next unit. You don't need to worry about that too much yet. But again, what you'll see is the NAND statement is the negation of and. So this is our and statement from what we've learned already, and it's got a not in front of it. So sometimes we use it, sometimes we represent it this way, sometimes we represent it using its formal symbol this way, but they mean the exact same thing. And probably something that's very, very important for you to know is that the statement is true when and is false. So it's literally, it's the negation of and, or the opposite of and. Okay, so P and Q. Normally, P and Q, well, if they're both true, then you would expect to get a true. But that can't be the case, because it's got to be the opposite. So it's not that. So normally, let me just write out what it would normally be. It would be true, false, 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 false. Not the case here. It's the negation of that. So we would say it's actually false. True, true, true. What you might want to do is write out your truth table for P and Q, or I can do that with you. That would be true, false, false, false. And then you could think of it as what's the negation of that? And then you would hopefully see that it's false. True, true, true. But we can do it here in one step if you do it in your head. Do the and first, and then negate it, and you can do it all in one big bundle. So now that we've covered NAND, you can probably guess we're going to move on to NOR, which the exact same patterns apply. It's not or. So whatever or is, hopefully you've got a good sense of what or means. It has the symbol that looks like a V. It's not that. So what we used to get is that if either of them are true, we would get a truth value out of this, a true value. Turns out that with NOR, it's the complete opposite once again. So we have our OR. This would be our OR gate, and then we have the NOT. So it's actually called a NOR gate. Just for some foreshadowing, right? And the NOR statement is the negation of OR. So once again, this would be our OR statement, and it's negated, so it's not that. And it has its own symbol. It has its symbol called NOR. The statement is true when OR is false. So again, it's the negation of OR. I've written, these are all the same ideas, but sometimes it takes a while to help it click. It's the negation of OR. So once again, normally, true, let's look at this truth table now. True and true, or true or true, if one of them is true, we should get a truth value, right? That's normally what we should be getting. So this is our regular situation if we had or. but we don't have OR, we have not OR. So we have the complete opposite of what OR would normally be. So if OR is false, so true and OR is false. Well, this must be false, 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 and true. Okay, so what I would recommend doing is, in your head, once again, think about what P or Q would have to be. So in this case, it would be true, 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 false, and then take that information and negate it, and then you'll end up getting your NOR. Alright, so it's a bit of a brain buster. All this stuff is a bit of a mental exercise for sure, but the more of these you do, the more natural it's going to be to answer these questions and to fill out these tables. Finally, we have exclusive OR. I'm not going to explain this one too much. We're going to be focusing on it a lot more when we do the next unit, but it just means we still have our OR, but we have this X in front of it, which means exclusive OR. So it still has the value, the symbol of OR, but it has this bar underneath. Or normally we would have an OR, and then if you add an extra bar in front, we'll deal with that a lot more in the next unit, that's the exclusive part. But don't worry too much about that. So the OR statement is true when exactly one of P or Q is true. So exactly one. In other words, XOR is true when P and Q are different. So that's what you should hold on to. That's your key, okay? That's very important. Let's see how it works. We know what the symbol is. It shows it right there. Let's do the truth table. So here we have true and true. So are they different? No, they're not different. T and T are the same. So it must come out false. In the next case, T and F, they're different. So if they're different, that's when it gives true. So something a bit weird to keep in mind when they're opposite. So for example, this case, or even the next case, would give true when they're different. It gives true. Or in other words, true when the inputs are opposites. I'm just trying to give you different types of language to describe this. And then finally, F and F, well, they're the same as each other. So it must be false. So this one's a bit weird. This one has very few analogies to English statements, and probably has never been anything that you have thought about before, but we're going to explore it a little more in detail in the next unit. But for now, when the inputs are different, then we have exclusive OR. One or the other, but not both. So I kind of fumbled over myself there, but I wanted to make it as clear as possible. Exclusive OR is when you have true for one of the inputs, but not both. So you should hopefully see that that's the same thing as saying it's true when they're different. If you have a true in there, one true, not two trues, then we get our truth value in the end. One or the other must be true, but we're not allowed to have one and the other. So it's exclusive OR. Hopefully I'm making a bit of sense here. This is our summary of just NAND, NOR, and XOR. So if you want to use this as a sort of reference table, be my guest. Might be a good idea to print this page, stick it on your wall or something, whatever gets you through. But this is a summary of what the results are going to be. Let's do some practice. Complete a truth table for not P and then something Q. So this is not. And then maybe pause the video and have a think about what this one is. Is it NAND? Is it NOR? Or is it XOR? And it turns out this is NAND. And think of it this way. We have and then the not on top means it's not and. So all we need to do here, well, we obviously need to fill out our initial inputs. So we'll do that. And the first thing we need to do is not P, because we can't get not P NAND Q unless we have not P to begin with. So not P. So P is true here, so false, false, and then the negation of the falses gives true. Now we can do our final statement, and think of it as whatever the AND result would be, and then negate it. So we have, once again, if this is like our 1 and our 2, this is 1, NAND 2. Whatever way you want to think about it. So let's see, T and F. Well, they're not both true, so it's false, but we now got to negate that, so it's true now. False and false. That would normally give false, so it flips to true. True and true would normally give true, so that switches to false. And finally, false and true would normally have to be both true, so it would be false, but we flip it, it becomes true. So again, that's a bit of a brain buster. It really messes with your head, especially if your foundational knowledge of your gates or your conjunctions, your connectives is a bit shaky. So make sure that you spend a lot of time going back through this if you're confused. You'll only get lost in the muck and mire if you don't spend the time practicing these tables and really getting them down. We can check all these results online, by the way. Let's just do that. So I've got my trusty Purple Monster and Psychic Duck, which you might have used by now and maybe not. Let's say not P, and then we need to find the NAND operator, and thankfully it's there, and Q. And I'm going to press Enter, or maybe I think I can click the Purple Monster. Oh, he deleted it. He didn't like that. I click the duck, and he says true, true, false, true. True, true, false, true. All right, my answer's fine. I've checked it. The intermediate result is there. False, false, true, true. That's not P. False, false, true, true. All right, so we're on the right track. Let's try another question here. I can just maximize this, I guess. Let's try this one. I recommend you pause the video, try to fill out this entire table, and then, you could even check your results on that internet site if you want. Internet site. I feel like my dad. You can go to the website. Check it out. So let's fill it out. These are all the possible inputs that we can have. All right, how many columns do we need? Let's say this wasn't set up for us. We would have 1 operation, 2 operations, and then 3 operations. You could do, what is this, by the way? That's NOR. And if you wanted to, you could do the OR operation first, and then do not OR, or, not whatever you get. But just for the sake of practice, I'm going to do it all in one. So this is our NOR, just so you know. Let me just write it above it like this. So we need not P, nor not Q. Not P we're going to need. We're going to need not Q in order to get not P nor not Q. And you have probably heard the word nor before. It's like, I shall not go to the store, nor shall I go to the supermarket. Anyway, bad example, but the word nor is actually in the English language. So not P, what do we got? False, false. True, true. What about not Q? False, true, false, true. And now we need to do nor, which is just an or negated. So normally false and false would give false, so we're going to give it a true. False and true would normally give a true, and we're going to give it false. True and false would normally give a true for or, it's false. True and true would definitely give a true in normal situations, but it's the negation. So maybe you want to remember this would normally give false, this would normally give true, this would normally give true, this would normally give true, but we have to negate them. So maybe I'll just put the negation on top. And if we negate them, then it becomes the result that we're looking for. All right? Again, take your time, do it a few times if you need to, and really get a good sense of how this works, because they're only going to get bigger and more complicated as we move on through this unit. So get a good handle on it now, and you'll be set up for the rest. Another example here. This is the last example we're going to cover. Complete a truth table for P and not Q. And it looks like an OR, but there's something going on there. And then not P, NAND Q. So let me label all these, just in case you're wondering. This is AND, you should know that. This is not, of course. This is NAND, not AND. And the middle one, what is it? Do you know what it is? Have you thought about it? That middle one is exclusive OR, because it's remember, or, this is or, this would be not or, because the not always goes on top, but exclusive or has the bar underneath, so be careful, there's a big difference. It makes a huge difference, it completely changes the result, okay? So let's fill this in. I recommend, once again, you pause the video and try this yourself, but you're more than welcome to watch me do this. So I like to set up my operations ahead of time. Not always, but sometimes. So let's see what I'm going to need. I'm going to try to tackle the first bracket first, which means I need P and not Q, and I can't get P and not Q until I have not Q. So not Q, and P and not Q. I'll do those two first. Not Q is this. Now if I look at P and not Q, this and this, or more specifically, this column and that column, what do I get? Well, T and F gives a false. They need to both be true, so let's remember that from before. For and, if they're both true, we get a true, and the rest must be false. Any other case is a false. That's why I can fill it out pretty quick there. Now, we can't get the XOR until we have the other pieces of information. And it looks like if I want to solve this, I've got two things to do. I've got to do not P, and I'm going to have to do not P NAND Q. And then I'll be able to do the final one. So not P, let's look back at the original column P and negate it. Now I'm going to need to do not P NAND Q. So follow me here. This is not trivial, we can say. This is our first piece we need to do NAND with. This is our second piece we'll need to do NAND with. And we're going to do 1 NAND 2. So remember, do and then flip it. So if they're both true, we would get a true and then we negate it. So true and false would normally give false. So true and false would normally give false. But we're negating that. So it must give us a true. Take your time with these. If you're not doing them as fast as me, that's fine. False and false would normally give false, but we're negating it because it's NAND. So we have true. True and true would normally give true, but we're negating it, so it gives a false. And finally, true and false would normally give a false, but we're negating it, and so it must give true. So, very tricky. Very, very tricky if you're just learning this. So, it has to do with the T and the T. That normally, T and T. T and T, dynamite. That was a bad one. T and T would normally give T, which means that T NAND T must give false. Right? And it's actually the only case that would give a false. So if you're really shaky still with your differences between ands and ors, then introducing nands and nors and zors is really going to be a pain in the butt. So do your practice now so you don't drown later. We have one more column to do. Not P. Oops, no, it's the whole thing. P and not Q. XOR. Not P. NAND Q. And that looks crazy, but let me use a different color to try and connect everything. We can call P and not Q. We've already got that done. Let's call that expression 3. And not P NAND Q, we can call that expression 4 here. Now there's different ways to represent this column, but I'm just trying to keep it organized. You don't even need to write those numbers on top if you don't want to. Just be careful that you keep track. So at the end of the day, I want this column. Let me get it a purple color. I want this. That doesn't look like purple. What's going on? Are these different? Maybe it's the background. Anyway, we want this column XOR'd with this one. I'm not talking about Power Rangers. You know what I'm talking about. We need to XOR it. So exclusive OR. I'll erase that in a second. I'll erase the highlighting, but to let us see it. Here we have false, XOR true. One or the other. If they're different, if these are different, then we get true. So they are different, so we get true. Let's play the same game. Are the next ones different? No. We have true and true. They're not different, so it's false. False and false. Are they different? No. False and true. Are those different? Yes, they are. So that gives us true. That's how XOR works. So that's kind of, like I keep saying, it's really a brain buster. It's quite a exhausting mental exercise. And that's why these videos I'm keeping shorter than the last ones, because there's a lot of things to keep track of. So let's double check our answer in our truth table here. Let's just write it out. So we have P and not Q. And, oh, it doesn't do XOR. Oh no. Well, let's do the individual parts and we can check. So P and not Q, let's see what that does. P and not Q, which is P and not Q, false, true, false, 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 true, false, false. That's what we get out of this. Let's do the other piece. So not P, NAND, Q. Our answer, not P, NAND, Q, should be true, true, false, true, 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 false, true. And so if we know those two columns are right, then it's just another small leap in logic or another logical operation to figure out the XOR. And so each of these individual conjunctions is not necessarily difficult in itself, but if you don't have a handle on why the rules work, you will have a very difficult time memorizing it. Now, once again, I did all this by logic, but if you need to use the tables to support your work, look at the table and try to work it out that way. It's always more important and more useful to understand the material, but if you want to use the reference tables to help you get through it, that's what they're there for, right? So after this topic, we've got conditional statements. So we have a few more symbols to do. The next topic, we're going to have this symbol, we're going to have this symbol, and then we're going to wrap all the way back around and go into English. So we're going to connect it back to English, do more truth tables, do what's called the converse, inverse, and contrapositive, also known as converse, inverse, and contrapositive, which looks complicated, but it's actually quite simple, and then we'll be done. It looks like there's a lot of unit left, but there's not. So we should be able to cover that in one video or one class, probably one class. All right, so spend your time working through this stuff. Make sure that it's making some sense, because again, the statements obviously get quite complicated, and you need to be able to take any combination of these together. Let me know if you need any help. This is a topic that sometimes students get a little stuck on, so just contact me if you need that help, and I'll be happy to give you a hand. Have a great day. See you in the next video.